First off, what do we mean when we say that two lines are parallel? What does this mean, Mashai? They'll never touch. So two lines that go on and on forever and ever, they will never touch, they will never cross, they will never get any closer or further away from one another. They're always going to be the exact same distance apart. What do we mean when we say that two lines are perpendicular? Stephanie. They intersect, and they intersect at a 90-degree angle. Now, are all lines either parallel or perpendicular? Dante says no. Why not, Dante? Explain. Yeah, we can have lines that, as Dante says, are just intersecting lines. Okay? One line comes along like this, the other line comes through it like this. They intersect, but they don't intersect at a 90-degree angle. This might be something like 30 degrees in here. So these are not parallel because they intersect. They're not perpendicular because they don't intersect at a 90-degree angle. They are something else, and we just call them intersecting lines. Okay? So sometimes the question is phrased, are these lines, classify lines as being parallel, perpendicular? Sometimes we just say that they are neither parallel nor perpendicular. And what we're going to do in this course is we want to know how to recognize perpendicular and parallel lines from their equations. In particular, we want to look at the slopes of their equations. So to recap some stuff we've already talked about. Parallel lines are lines that will never cross. Two lines are parallel if they have the same slope. Okay? So you can look at an equation and you can figure out whether two lines are going to be parallel or not. If we have an equation in the form y equals mx plus b, we know that this m right here is our slope. So you've got a little picture there in front of you showing two lines, y equals x plus 2 and y equals x. We got the equations over here, y equals x plus 2 and y equals x. What are the slopes of these two lines? What is the slope of y equals x plus 2? Slope is always that number that appears in front of the x here. If we don't see a number in front of the x, what number do we sort of assume is going to be there? Let me try it. Yeah, so this has a slope of 1. And, of course, same thing with y equals x. It also has a slope of 1. So both of these have a slope of 1. If they have the same slope, they are going to be parallel. And from the picture, you can see that these two lines, if we extend them on, they're going to stay the same distance apart. They're going to go on forever and ever. They're never going to cross. They're never going to get any closer together. So parallel lines are pretty easy. Perpendicular lines. Perpendicular lines intersect each other at right angles. We've already mentioned this. They have slopes that are what we call negative reciprocals. Okay? So what is a negative reciprocal? Well, let's take a look at an example here. Here I've got two lines that intersect at a right angle. That little square in there tells us it's a right angle. Our two lines are y equals 3x minus 4 and y equals negative 1/3 x plus 2. What is the slope of y equals 3x minus 4? Isaac, what's the slope there? The slope is 3. What is the slope of y equals negative 1/3 x plus 2? Yeah. Now, whoops, negative 1/3. There we go. How do we know that these two numbers, these two slopes, are negative reciprocals? Two things. There are two ways of telling. Number one, negative reciprocals always multiply to negative 1. So if I take my 3 and I multiply it by negative 1/3, remember, think of this as 3 over 1, I get negative 3 over 3 equals negative 1. I think an easier way of thinking about this is if your slope is a fraction, you want to invert the fraction. So basically flip it over. Interchange the top and the bottom, and then change the sign. Okay? So if I take my slope of 3 here, okay, and I write it as a fraction, 3 over 1, and then I invert the fraction, so interchange the 1 and the 3, and then make the whole thing negative, I get negative 1/3. Okay? So that's showing us that these two slopes, or these two lines, are negative reciprocals of one another, so the lines are perpendicular. Okay? So parallel, same slope, perpendicular, negative reciprocals. So let's look at some examples here. What we want to do in each of these cases here is state whether each pair of lines is parallel, perpendicular, or neither. And we want to do this based on our slopes here. So the first one here, we've got y equals 1/3 x plus 2 and y equals 1/3 x minus 3. Are these lines parallel, perpendicular, or neither? What do you think, Stephanie? How do you know that they are parallel, Stephanie? Because they have the same slope. Okay, 1/3 in each case. If we wanted to have a line that was perpendicular to these two, what would its slope have to be? What would be the negative reciprocal of 1/3? Jackie? Negative 3 over 1, or just negative 3. Excellent. All right, part B here. We've got y equals 3 over 5x plus 2 and y equals 4 over 5x minus 2. Are these parallel, perpendicular, or neither? What do you think, Chris? Neither. Absolutely. Slopes are not the same. Slopes are not negative reciprocals. All right, on to C here. Y equals 5 over 4x plus 3. Y equals negative 4 over 5x. Parallel, perpendicular, neither. Mishai. How do you know that they are perpendicular? Now, they don't add up to -1. They would multiply to -1. Okay? Or, what can you see about them? That they are flipped and the sign has been changed. Okay? Negative reciprocals. We need both of those qualities, okay, in order for them to be perpendicular. So, yeah, get in the habit of using this phrase, negative reciprocals. Okay? All right, our next one here. Y equals 2x minus 4. Y equals 2x plus 4y minus 3 equals 0. This is a tricky one. Our first equation, y equals 2x minus 4, we can tell right away what the slope is. Our slope is 2. We don't know right away what the slope of the second one is because it's not in y equals mx plus b form. It's in standard form. So we need to rearrange this so that it is in y equals mx plus b form. So let's do this. I'm going to bring the subtract a 2x there, add a 3 there to get 4y equals negative 2x plus 3. And then I've got to divide everything through by that 4. So y is negative 2 over 4x plus 3 over 4 is my equation in y equals mx plus b form. So anytime you see something in standard form, put it in y equals mx plus b form. Now, what do we think? Parallel, perpendicular, neither? Is there something we should do before we try to answer this? One more step we should do. Jackie? Yeah, so we should simplify this a little bit. Negative 2 over 4 is negative 1 over 2. Now we want to compare our two slopes. Negative 1/2 and 2. Parallel, perpendicular, or neither? Stephanie? They are perpendicular because those two slopes are negative reciprocals. Okay. Just hold on a minute. Okay. All right, our next one here, x minus y equals 5 and x plus y equals 1. What do you think? What would we do first? Andrew? Okay, so how would we do that? I'm going to add y there. I'm going to add y there. Oh, no, wait, that's not going to work. Sorry. Yeah, it will work. So I'll get, and then I'm going to move the 5 over there. What I get here is I get y equals x minus 5. Is that right? Yeah. What do I get over here? I get y equals negative x plus 1. Subtract x from both sides. Parallel, perpendicular, or neither. What are our two slopes here, first off? Tell me, Jackie. 1 and, not x, but negative 1. So 1 and negative 1, are these negative reciprocals or no? Stephanie? They can be. Yeah, so they're going to be perpendicular. Okay. Y equals 4x plus 4 and y equals x over 4. Parallel, perpendicular, neither. Well, let's figure out what the slopes are first. My slope here is 4. What's my slope for y equals x divided by 4? I got to rewrite it kind of like that. Now what's my slope? 1 over 4. Are these things parallel, perpendicular, or neither? What do you think, Stephanie? Neither. Why not? Why are they explain? Right. They're not the same, so they're not parallel, and they are reciprocals, but they're not negative reciprocals. All right, tricky ones down here at the bottom. X equals 5 and y equals 7. Parallel, perpendicular, or neither? These are the ones that everybody always forgets about. And you got to sort of think about what the graphs are going to look like here. Andrew, why are they perpendicular? Say that again? Never mind. Okay. What kind of a line is x equals 5? I'm going to put a little picture down here at the bottom. Oops. X equals 5 is a vertical line. What about y equals 7? Stephanie? It'd be a horizontal line, something like this. Are these two things perpendicular? Yeah, they intersect at 90 degrees. One of them's horizontal, one of them's vertical. Okay? So, yeah, let's say vertical, and this one is horizontal. Okay, you thought we were doing H? Okay, go ahead. Talk to me about H. X equals negative 5 and x equals negative 1/5. They're neither? Why? What kind of lines are these? Mashayat's got it here. She doesn't want to say. She thinks she has it, though. Sorry? You don't have the right answer? Well, what kind of a line is x equals negative 5? What kind of a line was x equals 5? Vertical. So x equals negative 5 is going to be vertical. And then while I'm writing this down, you're all thinking about what is x equals negative 1/5 going to look like? Is this going to, what kind of a line is x equals negative 1/5? It is going to be vertical as well. So if both of these lines are vertical, are they going to be parallel, perpendicular, neither? What do you think? Parallel, yeah. Okay, beautiful. All right, We're going to stop